Hi guys. So in this video we'll see how we can find intersection between two lines using Python, but let's first understand the basic concept of this. Okay, so what's the line? A line can be like this, the green line, and basically we want to find the intersection between this green line and this blue line. Blue line is just a vertical line at x equals x naught. Okay, so a line actually a set of coordinates where we can actually draw a dot. You connect all the dots, you get a line. For line 1 or the green line, we have set of points, say x and y points. So basically a matrix of m rows and 2 columns. So n can be very large, say 10,000 or even 20,000. It can be very large. So we just draw all the points x comma y, say x1, y1, x2, y2. All the points are plotted here. So we get the green line. For the blue line, well, the equation is simple. X equals some constant value is the equation of a vertical line that is parallel to the y-axis. So for this blue line, all the x values should be the same, because that's the equation, x equals constant, and y value can be anything. Okay, so that's our x and y coordinate for the blue line, and here n is the number of rows or number of elements in this matrix or data set. So say x blue represents an array or list of numbers, that is the x coordinate of the blue line, that is lots of points, all are x naught, and x green is the x coordinate of the green line, all the points are here. We take the difference of all the points. Well, in equation it is just x1 x2 lot of numbers minus just the x naught value times a matrix consists of all ones in its column. Okay, we take the difference, we call it delta x, and delta x contain positive and negative values because the value of x for this blue line can't be anything. It's just a constant. But for green line, it is some at this point, for example, the value of x of this green line is smaller x than x naught, but here it is greater than x naught. So if you subtract those values, you will get some negative and some positive numbers. Okay, then we'll take the sign, only the sign, that is if the value is negative we choose it as -1. If the value is positive, we say it's +1. No other values, only +1 and -1. So this sign, we have some function, for example, that will calculate the sign from the difference of these of this list of values. So then what we do, we actually we plot the like sign. Then basically we have this kind of line. So on the left hand side all the values are negative, on the right hand side all the values are positive. It can be anything, it can have some arbitrary shape, basically like this. But at the end of the day, we don't want any arbitrary shape. We actually going to set -1 if the value is less than 0 and +1 if the value is greater than 0. Okay, so sine function actually do that for us. So that's why we have this straight line, a jump, then straight line, and it's a step function. And if you take a derivative of the step function, you get a delta function, and the peak of that delta function will be at x equals x naught. So say a is the we take a derivative of del x underscore sine, we get a, which is the delta function, and the maximum point of a will give us the index of our value, will give the x naught coordinate. So argmax is a function that will help us find it. Let's see the Python code. So here I have few files. This is just the Jupyter notebook file, and this is a shell script. And if I run this script, I'll just the Jupyter notebook will just open in this folder or directory, and this is my data file. Okay, so I have already opened the Jupyter notebook. Here you can see these three files, and if I click it, I have actually opened it here. So still I'm gonna cross it, so it's open here. So I have few modules, libraries written here. I'll load them up, and the next line is actually os.list dir. It will list all the files in the current directory or current folder. That is the dot means current folder. So I have 3 files, and this dot IP1 and B checkpoints is a hidden folder. We don't need to be concerned about this. Okay, then the file name is just this is the file name. So I'm going to print it. So this is my file name, and let me load all the data of this file from this file using numpy module. So import numpy as np. So np is a symbol that will basically instead of writing numpy, I can write np here. So I have all the data in this data variable. I can list it here. So in this data I have 4 columns, and how many rows? Well, looks like only 1 2 3 4 5 6 rows, but that's not the case, because all the dots here tells us that there are more rows, but it's not displayed here. So if I print it, so there are 40,000 rows and 4 columns. So we just want the first and the third column. So index of the first column is 0 and index of the third column is 2. So let me load this using this command. So this command actually is basically very simple. So let me explain it. So this is the data variable, and you use the index symbol for using this square bracket. You place a comma to separate row and column inputs. So this is for row, and second input is the column index. So I basically want all the rows, so I'll place a colon here, and I want only the first column, so I'll write 0 here. Okay. So if I plot it, it will look like this, similar to what we had in our graph, the green line. Let me check the shape of this slice of the data here. It says 40,000 comma 2. Well, in the second index element, that is for the columns, I can write a tuple here, 0 comma 2. That will return me a list or an array of 40,000 rows and 2 columns. Those 2 columns are basically the first and the third column. So 0 comma 2, I can write it like that. So this short form, I need to write this dot t to transpose these data variable or data matrix. Let me plot it again. So this is my graph, and say I want to draw a straight line at x equals 0.7 here, somewhere here. So how can I draw this? Well, any line is basically only a set of consecutive points. So x1 dot shape, that will tell me the number of rows in x1 variable, and I want basically in my new straight line, number of data should match this 40,000 value. Number of data in x1 and number of data in x2 should be exactly the same. Okay, so what does this command do basically? So np.once, it will create a one column only who consists of only 1, a constant 1. and if I pass x1 dot shape and the first element, which is just 40,000, or I can just write 40,000 here like this. Okay, times say 0.7, this number right here. This is the x2. If I print it, so only 0.7 as the x value of the straight line. Okay, for y2 I'll do a clever trick. I don't want any y values. I want only y values starting say at the minimum point of this line to the maximum point, probably 0 to 1, but it can be something different for different lines. So let's keep it in a general form. np dot minimum x1, so starting point is the minimum of y1 variable and ending point is the maximum of the y1 variable, and we want this number of points. np dot linspace takes 3 arguments. First one is the minimum value, second one is the maximum value, and third one is the number of values that I want. So this is my array, so starting from 0 going to 1. If I plot all the x1, y1 and x2, y2, that is both the curve and the straight line, I get something like this. I basically want this point, this intersection. So what do? I take the difference, x1 minus x2, just I have described in the previous part of this video, or the first part of this video. Delta x is just this. As you can see, first we have some negative numbers, but this list ends with some positive numbers. These numbers may be different, as you can see here, but we don't want that. We want all the values to be either +1 or -1 to create a step function ultimately. So this is the step function. You can see starting point points are all -1 and ending points are all +1. So this is a step function. There is a point where for the first time the value of -1 becomes +1 somewhere in the middle. So now we take the difference, np.diff. So as you can see, all these are zeros. Basically it's because the jump is in between the data function. So if I write it like this, np.diff, np.max, that will tell me the maximum value is 1. Okay, so we actually don't need much of this, just this line. When you have this delta x sign, you do the differentiation using np.diff. You pass in the value of the array, and you execute this command, this function argmax. This is basically will give you the index of the element with the maximum value in this list. Okay, so instead of writing a different variable and assigning it to that variable, I'm just going to do it in one line. So this selected part is the delta function, and argmax will give the index of the peak point of the delta function, that is the maximum value of the index. So let me execute it. So 27998 is our maximum point. So if I execute this cell right here, you can see we have this dot. So this is our intersection. First part is the same as before, here x1 y1 x2 y2, and second part is x1 idx y1 idx. That is we are actually only plotting this point, and this O right here tells us that this is just a point. We're going to draw the points, not a line. Okay, so we can do all this in one line. Once you have all this x1 x2 and y1 y2, you can just execute this line. You take the difference, you take the side and the differentiation, then argmax. So in one line you have this intersection. Okay, so let me check what is the x and y value of this point. This is the x value, this is the y value. It's not exactly 0.7, but it's very close to 0.7. Okay, in reality you may not get the exact point because uh, a lot of things are involved. It can be slightly some money off, but it's very close, 0.699975. Okay, thank you for watching this video.